Hello, this is Pure Mathematics 2 Edexcel, and today we'll be doing integration chapter number 8. So the first rule of integration that we probably know from our GCSE is that if you have x to the power n, and that is y, and then if you integrate y with respect to x, so you have to integrate with respect to something. So with respect to x, then y basically means x to the power n. So you want to integrate that. And integration basically means, the simplest rule is to add 1 to the power of x and then dividing by that new power. So dividing by the new power, that is basically what integration is. And after integration, if this is an indefinite integration, we will talk about definite and indefinite integration later. Basically, indefinite integration is something which does not have limits on top and bottom. So for an indefinite integration, you have to add a constant to the integral. So this is the basic rule. So let us look at an example. For example, you have y equals 2x square plus 10. The integration of y with respect to dx is basically the integration of 2x square plus 10 with respect to x. Therefore, the rule that we learned, we will leave this 2 as it is. We will not touch this 2. So 2 is as it is. X, the power of x will increase by 1, that is 2 plus 1 equals 3, and then we divide this x by the new power, that is 3. The power of x here, well, we don't have any x here, but we can say that the power of x in this expression is 0, and we know that anything to the power 0 is basically 1, so we can say that we have an x here to the power 0. So the power of x will increase by 1, that is 0 plus 1 is 1, then we divide by the new power. And since this is an indefinite integration, so we have to add a constant to the integral. This is the answer. Moving on to something a little bit more challenging, when we have something like this, something in a third. So x square, something like this. What we have to do is we always have to bring the x in this form, x to the power something, or else there is a chance of a calculation error. So this can be written as, since this is x square, so we can write this third in this form, 1 by 3. Okay, so this can be written as x to the power 2 by 3. This is y. Now the integration of y with respect to x is basically the integration of x to the power 2 by 3 with respect to x. And the same rule follows, 2 by 3 plus 1, 2 by 3 plus 1, and then divide the integral, divide this expression by the new power. And since this is an indefinite integration, so you add c. So these are basically the rules and how we manipulate surds to find the integral. Now suppose that we have this sort of an expression, but now we have a power. What to do? What we want to do is, we don't want to keep any power. We don't want to have a power over a fraction, power over a function during an integration. So we want to expand this power so that we don't have any power over a whole function. So this can be broken down in using the formula a plus b whole square formula. So this is a, this is b, a square, that is 4 x to the power 4 plus 4 x square plus 1. Okay, so this is basically y. If you want to find the integral of y, you can basically follow the rules that we had just learned and integrate them separately, and don't forget to add plus c. The purpose of this example was to show you that before continuing with integration, where there are powers, you have to first break the power and convert it into something which does not have an overall power over a function. And just to make the question tricky, if the question is very tricky, the question might ask you to integrate 2x square plus 1 to the power 3. In that case, you can separate that 3 power in 2x square plus 1 to the power 2 and 2x square plus 1. Then you can expand this part and then multiply this part with the expansion. Moving on to definite integrations. So definite integrations are the ones which have limits. The higher limit 4 and the lower limit 2. So now let us integrate 2x square plus x with this limit. Okay. So now if you integrate using the same rules, that is 2x cube by 3 plus x square by 2. Okay. So after doing this, after doing the integration, the extra step that we have to do because of the definite integration is that we have to substitute these higher and lower limits of x, first the higher limit and then the lower limit. So first we put 4 in place of x, the higher limit, and then we put the lower limit, that is one interesting thing to notice here is that if you break this bracket, this c and this c will cancel out. That is why it is not necessary to put a plus c during definite integration. This is not wrong, but it will just cancel out. So it is not necessary to write this value or to write this c in your integral. You will get the answer using your calculator. The last concept that we will be learning today is the concept of area. So suppose that we have this area. We have this area that is 2, 0. That is the y-axis and this is the x-axis. This is the origin. So this has an equation of x minus 2 or x square minus 2x, and you want to find out the shaded area, basically the area between the curve and the x-axis. You want to find this area. So the formula for finding the area is basically the integration of your equation with respect to x, and for the limits you have to put these two limits, the places where your curve crosses the x-axis, and the limit which is small should be below, that is 0. The limit which is larger should be on the top, that is the higher limit, that is 2. We know that y equals x square minus 2x, so we will integrate x square minus 2x with respect to x, then x cube by 3, 2x square by 2. I'm not writing the c because it will cancel out, 2, 0. So basically this will turn out to be 8 by 3 minus 4, the whole thing minus 0 minus 0. So that is how you get your answer, and this is how you calculate the shaded area under the curve. Things get interesting when we have an area that crosses the curve, that crosses the x-axis both above and below the x-axis itself. So suppose that you have a sine curve, and we know that a sine curve continues here as well. So here it is pi, and here it is 2 pi, and here it is minus pi. That is a typical sine curve. So you don't need to know about sine curves in this particular chapter, but this is a sine curve, y equals sine x, and you want to calculate the area between this part and this part. So one common mistake is that many of us integrate this function with respect to x and put the limits as minus pi and pi. After doing this integration, you will notice that your answer turns out to be 0. That is because we have equal amount of area both below the x-axis and above the x-axis. So what happens is, when you do this calculation, the upper and the lower areas cancel out. Instead, what we want to do is, we want to calculate the area in two parts. One part, this is one part below the x-axis, and this is the other part above the x-axis. So I'm calculating the lower part, the upper part at first, that is part 2. So I'm going to integrate from 0 to pi. this part is basically 0 to pi, so I'm going to integrate 0 to pi, and this is no longer 0. So sin x integration is basically minus cos x pi 0. And we know that we first put the value of the upper limit minus the value of the lower limit. Cos pi is basically minus 1, so minus 1, and cos 0 is 1, so plus and minus plus, cos 0 is 1, so this is basically 2 unit square is the area above the x-axis, and this is for part 1 only. Since sine curves are repetitive, they're periodic curves, so we can easily conclude that the area above the x-axis, this area is equal to this area, part 1 area. So the area of part 1 is also 2 unit square, 2 square units. Finally, the total area equals 2 plus 2. One important thing to remember is that when your area is under the x-axis, sometimes the area might turn out to be negative. After doing the integration calculation, sometimes your area might turn out to be negative. In that case, what you do is you take the modulus of that number. For example, after doing the integration and finding the area, you find out that your area turns out to be minus 10, negative 10. Because integration basically is a mathematical operation, and there is no rule that says that integrals cannot be negative. So it might turn out to be a negative number, especially if your area is under the x-axis. So in that case, what you do is the area cannot be negative, so you take the modulus of minus 10. So the modulus of anything is basically the magnitude of that number, that is the number itself, and then you continue to add the areas individually and find out total area. Our next topic is how to find the area between two curves. So imagine that you have this curve here, which is y1, and another curve here, which is y2, and you want to find the area between the two curves. The formula for this is area equals y1 minus y2 dx. So the mistake that you saw that I am making right now, it is a very common mistake, and the way you understand that whether you put y1 or y2 in front is that the curve which is above, you should put it first. So y1 is above y2, here y1 is above y2, so y1 minus y2. So once again, I'm not going into the derivation, I'm just giving you the formula, then you can work it out. As for the limits, you have to work out where the two equations intersect, and from there you can find the point of intersection as x1, for example, and the other intersection we can see from here, it is 0. It could be something else as well. If they intersected somewhere else, it could be x2, but here it is 0. So my lower limit, that is the leftward limit, is 0, and my upper limit is x1. So you will have equations for y1 and y2. So after putting those equations, you can work out the area. For example, if your y1 has an equation of minus x square plus 2, I don't know, it is not accurate, but I'm just showing it for the sake of showing you how it works. And maybe this is 2x square plus 2x. These are not accurate sketches. I'm just showing you how to put the equations. And maybe, just maybe, once again it is not accurate, maybe they intersect at 2. So my limits would be 0 and 2. My y1 is minus x square plus 2. My y2 would be 2x square plus 2x. That is my y2. And then after simplifying them, I get minus 2x square, minus 2x, and this expression you have to integrate and find out the area. And if by any chance your area turns out to be negative, what you do is you take modulus of that area and just get the positive value. Moving on to the last concept of this chapter, that is the trapezium rule or the trapezoidal rule, which allows you to find the area even if you don't know how to integrate a particular function. So for example, you have this function here, you have this function y equals fx, okay, you have this function here, but you don't know how to integrate this function. For example, once again, this is not an accurate function, just for example, maybe you have something like this, okay, some difficult function which we don't know how to integrate. Then what you can do is, for example, you have to find the area of this region here from 1 to 5. This region you have to find out, this area you have to find out. So what we can do is, the question will specify, the question will tell you, for example, to divide this area into 4 strips. Dividing this area into 4 strips, we get something like this, which looks like this, okay. So we have 4 strips here. So if this is 1, this is 2, since we have divided it regularly, so this is 1, this is 2, this is 3, this is 4, and ultimately this is 5. So you know your function, although we cannot integrate this function, but we know that if we put the value of x here, we can get the value of y. So what you do next is, you create a table of x and y. So this is not an accurate example, the values are not accurate either, I am just showing you how to do the math. You can find similar examples in your book 5. So for example, for 1 you get a y value of 3, for 2 you get a y value of 5, for 3 you get a y value of 7, for 4 you get a y value of 9, and for 5 you get a y value of 11. So you can see that the sketch is not very accurate, but it will suffice. 5, 7, 9, 11. So for each x coordinate we have the y coordinate, okay. So your shaded area is this. Let me mark the area. This is your shaded area, and this is the area that you have to find. So the trapezium rule says that the area equals half h y naught plus yn plus 2 into y1 plus y2 and so on. The formula might look confusing, but let me explain. This h that you see here, the h here, this is the common interval or the common width of the strips. So here we have 4 strips, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. The common width, the width of each strip, the width of this strip here is 1. This strip has a width of 1, this strip has a width of 1, this strip also has a width of 1. It is important that all the strips have equal width. So this width can vary math to math, but here it is 1. So our h has a value of 1, okay. Y naught. Y naught is the leftmost value or the first value of y, okay. So here the first value of y, that is the y corresponding to 1, is 3. So 3 is my y naught. Yn is the last value, that is for 5 I have a value of 11, so 11 is yn. And this y1, y2, y3 and everything, these are the things that you have in the middle. So this is your y1, y2 and y3, okay. So the formula goes like this, that you put the first value of y, that is y naught, the first value of y, you add the last value of y, that is 11, and then you add 2 times all the other values of y, that is 5, 7, 9. So let me explain this formula again. H is the common interval, the common strip interval, that is 1. Y naught is the first value of y, that is 3. Yn is the last value of y, that is 11. Then you add all the middle values of y, that is 5, 7 and 9, 5, 7 and 9, and then multiply them by 2. Not going into the derivation, you can find the derivation in your book, and from here you can calculate the area. So this little concept should allow you to do rest of the maths from this chapter. If you found this video useful, don't forget to express your thanks by subscribing and pressing the bell icon so that you get the update when I solve a new problem for you. Thank you for watching.